Okay, we are going to pick back up on page 25, working on those normal distribution practice problems. So we skipped B and C because these talked about z-scores and we hadn't looked at z-scores as part of our notes yet. And now that we've seen the z-scores component, let's talk really quickly about z-scores. So here's distribution A, here's distribution B. We identified the mean and standard deviation for both of these last time. So I want to know what value in A corresponds to a z-score of +2. So +2 means 2 standard deviations above the mean. So if I go to A, we know that here's our mean, +2 would be 60. So that would be a z-score of +2. A z-score of -1 in A would be 1 standard deviation below the mean. So that would be 30. For B, same idea. A z-score of +2 in B means 2 ahead of the mean or 2 greater than the mean. So 1, 2, here would be +2, that's 75. And a z-score of -1 would be 1 below the mean. So that would be 60. Now let's turn to page 26 and take a look at some more examples. Number 5 on page 26. It says, according to the St. Bernard Club, your 170-pound Bernie is too hefty compared to other dogs his age. Bernie goes on a doggy diet and his weight decreases from 2 standard deviations above the mean. So he's currently at +2, or he was at +2, to 2 standard deviations below the mean. So we're going to -2. If the standard deviation for a St. Bernard's weight is 5 pounds, what's the mean weight for his age and breed? And what's his weight after the diet? So we know when he's 170 pounds, he's 2 standard deviations above the mean. And I'm going to sketch a little curve here. So right at our mean, we don't know what that is, but that would be in the middle. 1, 2, 3, 1, 2, 3. We know that he was 2 standard deviations above the mean, and that was 170 pounds. We know that he ends 2 standard deviations below the mean. So right here is his end weight. And here's where he started. And then they tell us that the standard deviation is 5 pounds. So that means my labels are going to be in increments of 5. So this would be 165, 160, 155, 150. The mean weight for Bernie's age and breed would be 160 pounds. And his weight after the diet would be 2 standard deviations below. That's 150 pounds. So even though we didn't start knowing the mean, since we knew where on the distribution we were starting at +2 and what that value was, we could use that and the standard deviation to be able to fill in the rest of our graph. You're going to want your calculators for the rest of our examples for today. Example 6, or number 6, I should say, if you take an exam and your score is the same as the mean for the class, what is your z-score for the exam? So your score is equal to the mean. So what is your z-score? So we can actually use our chart right above here. Let's say your dog weighed exactly the mean of all the St. Bernards. What would be your dog's z-score? So we talked about how this is +2, this is -2, this would be +1, this is -1. So right in the middle there, the mean z-score would be 0. Remember, the z-score is telling me how different we are from the mean. If we're not different from the mean, then that means your z-score would be 0. You're not different from the mean at all. For problems 7 and 8, we're going to use a normally distributed set of test scores with a mean of 100 and a standard deviation of 15. So for the next couple, mean of 100, standard deviation of 15. Find the probability that a person selected at random will have a score between 80 and 120, between 80 and 120. Now, if I wanted to, I could set up a little curve here. I know my mean is 100, my standard deviation is 15, so this would be 115, 130, 145. And then I could go back the other way 85, 70, 55. Now I'm asking between 80 and 120. So that's going to be just below 1 standard deviation to just above 1 standard deviation. Okay. These are not values I can figure out using those percentages from the very start of our normal distribution note. So I need to use my calculator here. So I'm going to pull up my calculator. And again, I like to do these in a spreadsheet page. So just in any blank cell, I'm going to hit the menu key. I'm going to go to statistics, distributions, normal CDF, and I'm going to enter all of our information. So our lower bound here is 80. I'm going to hit the tab key to get down to the next box. Our upper bound is 120. Tab to the next box. Our mean is 100 and our standard deviation is 15. Once I've got all that information entered, I'm going to hit enter. And there's my probability. So 0.816 if I round to 3 places, 0.816. So my probability is not quite 82% that I would have a score between 80 and 120. Okay, it should make sense that this is more than 68 because I know this chunk is 34 and this chunk is 34. So together I get 68 there, but I'm outside of that. So it should be more than 68. Less than if I went all the way to the second standard deviation. So number 8, find the probability that a person selected at random will have a score between 55 and 145. So I'm using the same distribution. I'm going to go back to my calculator and do the same thing. So let me pull up my calculator here. And I'm just going to go down to the next box, menu, statistics, distributions, normal CDF. My lower bound this time is 55. My upper bound is 145. Our mean is still 100 and our standard deviation is still 15. And there we go. I get 0.997. Okay, round to 3 decimal places. And again, this should make sense between 55 and 145. So 55 is here, 145 is here. So we could have added up our percents and we would have said this should be close to 100 because that's within 3 standard deviations. What we're actually seeing here is a more in-depth statistical principle called the empirical rule that says almost everything should be within 3 standard deviations. You'll talk about that more if you take dual credit stats or AP stats, but that's what we're seeing here. Per our calculator at this time, just about everything should be within 3 standard deviations of that mean. And now let's look at less than 60. So 60 would be in here somewhere. What's the probability that we're smaller than 60? So this time, when I pull up my calculator, I'm going to go to same thing, menu, statistics, distributions, normal CDF. This time I don't have a lower bound. It says less than 60. So I'm going to leave the lower bound that my calculator gives me and just tab to upper bound. 60 is the biggest score that we're interested in. Our mean is still 100 and our standard deviation is still 15. There we go. Very, very, very small probability that I'd be less than 60 here. So 0.004 if we round to 3 decimal places. Okay, 0.004 that we are less than 60. And then our last question on page 26, number 9. In Florida, the daily water usage per person is normally distributed with a mean of 110 gallons and a standard deviation of 10. So our mean is 110 and our standard deviation is 10. Between which two values will 68% of the daily water usage per person lie? So 68%, that is from 1 standard deviation below to 1 standard deviation above, okay? Within 1 standard deviation of the mean. So I'm just going to do the label at the bottom on this one. I know my mean is 110, and then 1, 2, 3, 1, 2, 3. And with a standard deviation of 110, as I move forward, this would be 120, 130, 140. As I go the other way, 100, 90, 80. So 1 standard deviation below, that'd be 100 to 1 standard deviation above, that'd be 120. So I would expect this to be within 100 to 120 gallons. I would expect 68% of our daily water usage to be between 100 and 120 gallons. For part B, what is the probability that a person selected at random will use less than 110 gallons every day? So less than here, that should be about 50%, 0.5 for probability. If I wanted to do this on my calculator, I would use the mean and standard deviation we were given. I would use the default lower bound in the calculator, and I would use 110 as my upper limit. Since we're dealing with values that land right on those standard deviation lines for this one, I'm going to use those percentages from our table. And then C, what's the probability that a person selected at random will use between 98 and 112 gallons a day? So just outside here and right here-ish, just ahead of our mean. So this one, I'm going to go back to my calculator. And again, any empty square is fine. Menu, statistics, distributions, normal, CVF. My lower bound here is 98. My upper bound is 112. My mean is 110, and my standard deviation is 10. So we get 0.464. Remember when you're using your calculator to be careful about what you plug in and where. Remember, if we're not given a lower bound, use the default on the calculator. And then as I talked about in your notes, when you set that upper bound, if it said something like, what's the probability that we're greater than 125, maybe greater than for that upper bound, make sure it's at least 3 standard deviations away, more than 3 standard deviations away. So for this one, if I had to pick an upper bound, I would do something like 200 or something that's far outside of the 3 standard deviations that I got here.